Okay, so our first set of example problems we have to simplify this first problem, 4.92 to the 0. 4.92 to the 0, 1. The second problem we see has us take negative 143 raised to the 0. We have to simplify it. We're going to get 1. Number 3, we see 18 to the negative 1. Oh, that's not an exponent of 0. We have to remember that negative exponent rule, which takes that power and puts it in the denominator with a positive exponent. So this is going to be 1 over 18 to the 1, which is just 1 over 18. So there's the first 3. Then the next examples get a little more crafty. So the next set starts with number 1, and here we see 3m to the negative 2. And the directions say simplify each, and it says use only positive exponents in your answer. So we see a negative exponent. We have to deal with that. Now be careful. That negative exponent is only applied to that base of m. If it was including the 3, you would see 3m in parentheses raised to the negative 2. But we don't see that. So this is the only one that has that exponent of negative 2. So this is the one that's going down in the denominator with a positive exponent. Where does the 3 go? Well, let's just leave it alone. So 3 times 1 over m to the negative 2. M to the positive 2 once we put that down in the denominator. We could answer it this way. That's perfectly fine. I don't like to leave it that way because I see a fraction and I can make this be just one fraction. If I put that 3 over 1, I can see, I multiply numerator by numerator, denominator by denominator, and I can give my answer as 3 over m squared. That's what we get there. So let's take a look at the next one. Do I have room? I do have room. So number 2, we have 4m in the quantity to the negative 2. This one has everything, the entire base, that 4m has that exponent of negative 2. So this whole base is going in the denominator. So we're going to have that whole base 4m squared in the denominator with a 1 in the numerator. Now I'm officially out of room. Let's move to number 3. So number 3, we've got 5x to the 0, w to the negative 3rd. Okay, this is getting a little more interesting. So here, this 5 doesn't have an exponent of anything other than 1. Any number or any expression you see that has no exponent written always has an understood exponent of 1. Which a 1, 5 to the 1, nothing happens to it, it just becomes 5. This x has an exponent of 0. We remember anything to the 0 is 1 as long as that x isn't 0, which there's nothing telling us it's 0, so we can write that as 1. This w has a negative exponent, so that's going to go down in the denominator with a positive exponent. So this is going to be 5 times 1 times 1 over w cubed. And multiplying by 1 just keeps everything the same. If I put the 5 over 1, I think you can see that this can be written as 5 over w cubed. And that's what our answer is. So let's take a look at number 4. Number 4 says x over w to the negative 3rd. Ooh, that's kind of nasty looking. Alright, that x only has an exponent of 1. Nothing's going to happen to that. It's going to stay as x. This w to the negative 3rd is going to be expressed as a 1 over w to the 3rd. Okay. Well, I'm going to tell you this. Math teachers don't like to have fractions within fractions. So this division, we're going to change that division to multiplication of the reciprocal of that and see what we get. So this is going to be x times, instead of x divided by, x times the reciprocal of that. The reciprocal of that is w cubed. Well, x times w cubed is xw cubed. And we're done. Here, I would like you to notice this. Look where that w to the negative 3 ended up. It basically ended up in the numerator with that x, didn't it? And this is where I like to tell people, I think of negative exponents not as flipping, but as repositioning. If you have a base with a negative exponent in the numerator, it's going to show up in the denominator as that base with a positive exponent. If you have a base with a negative exponent in the denominator, it's going to show up in the numerator as that base with a positive exponent. So that, when I see a problem like this, and I'm asked to simplify it, so let me go back to the original problem, x over w to the negative 3. What I do is I don't actually do this step. There's nothing wrong with it, I just don't do it. I circle the power, the base in the exponent with the negative exponent, and I draw an arrow to reposition it where it should go. So that should go up to the numerator with a positive exponent, and then I'm done. It's as simple as that. So let's take a look at number 5 now, and maybe we can make some sense of that problem. So number 5, we have m to the 0 all over a, b, c to the negative 1. Okay, 0 exponent. We remember anything to the 0 is 1. So that's just going to be 1 over a, b, c to the negative 1. Hey, we've got a c that has a negative 1 exponent. That's going to be repositioned, since it's in the denominator, it's going to be repositioned to the numerator with a positive exponent. So it's just going to be c to the 1, which we don't write to the 1. We just write c, and those a and b's are going to stay where they are. And we're done. Those don't move because those don't have negative exponents. They stay exactly where they are. And number 6, let's take a look. Number 6 is 3x to the negative 2 all over 5y to the negative 3. Okay, that x to the negative 2, that's a base with a negative exponent. The 3 has an exponent of 1. It's not going anywhere. It's going to stay there. This 5 has an exponent of 1. It's going to stay right where it is. That is going to go in the denominator. This y has a negative exponent. So that is going to go up to the numerator. Remember, a negative exponent will reposition. So we can just reposition, keep those where they are, so we can write our answer. We're going to have a 3 and a 5 staying right where they are. That x to the negative 2 is going to be down in the denominator like that. That y to the negative 3 is going to be up in the numerator just like that. There it is. There's your answer for number 6.